So we are Team Biopower, and we'll start with Archana, and she'll introduce what our project is about.
Good morning, India, and good evening, US. We are Team Biopower. Moving to the problem statement, in every part of India there is a problem of waste management, waste disposal, etc. And also there is a high demand for energy sources. Even though for this high demand, the LPG gas cylinders availability is become shortage, and also here the idea biogas plant arises, and the individual biogas plant, which has a lot of advantages, but it didn't penetrate into much consumers in India because of certain reasons. The existing biogas plant in India are expensive. It costs around almost $380, almost 20,000 to 22,000 rupees, and also they are not extremely efficient because the consumers feel very difficulty to make the waste particles into small portions, and it takes time to generate energy, to generate gas, etc. And also it requires daily usage. Even though a particular consumer didn't use the biogas tank for 2 or 3 days, the moisture content in the tube associated with the tank become condensed and form water, and this water block the free flow of gas into the tank. So our team Biopower has a mission to make a biogas tank which is compactable and cheap for the common people in India, and also it should be efficient, which they are using, much efficient than the existing biogas plant in the market. Thank you.
I'm sorry about that. I don't know why that. I thought it was.
So like most of the biogas tanks you see in the market are these like huge tanks meant for large scale uses. So if like looking at the United States, the only people that you see using biogas tanks are like large plantation farms that basically generate tons of waste each day. But in Kerala, like, most of the people are living in like households, they're basically small farmers. So what we want to do is we want to focus on the other side of the spectrum, is basically focus on small biogas tanks and like for small scale uses. And so currently right now the farmers in Kerala, they're spending about $12 per month on LPG, and we feel that even with a small biogas tank, that even if it generates like a limited amounts of gas, it'll still be sufficient for like their daily uses such as cooking, and they can use the fertilizer for farming. And so we did some preliminary research, and we found that different producers around that region were producing around 200 tanks per month. And considering that there are over 30 million people in Kerala, this is a pretty large market for us, even though tanks is a pretty established field. Right, so to iterate, the reason why we don't see so many households in Kerala using these small biogas tanks is because of the three things: cost, maintenance, and efficiency. And so the last term, after some brainstorming, we tried to target the efficiency problem. And so if you think about in the large scale biogas tanks, what they normally do is they have some kind of shredder that shreds the input before actually putting inside the tank. But the small scale biogas tanks, they don't have that additional feature. And we thought, all right, maybe if we can take that idea and somehow put it onto these small scale features, we can make it more efficient. Because there's research out there that shows shredded input generate gas more efficiently. And so after a couple of prototypes, we figured out, so basically this led us to our first idea, which is the food shredder, or the waste shredder idea, which basically, as it sounds, is manually shreds input before you put it inside the tank. But after a couple of prototypes, we found out that the cost of making that shredder compared to what it costs to actually buy it was much greater. And so even though there is some value to shredding the input, the amount of money that our customers would have to spend would make this a pretty unattractive asset. And then we had some other problems that were introduced, such as like introducing a new add-on, such as the future introduces new problems such as maintenance issues, such as like what happens if the blade breaks, what happens, or who's going to do the shredding, or how are we going to clean the tank, how are we going to clean the shredder. And so more and more this idea became less and less marketable. And then at the end of the term we realized that, okay, even though the shredder is a great idea, we want to keep it, for the next term we're going to stop focusing on building the actual shredder and moving on to a new idea.
So based on our first term experience, we decided to take a more fundamental approach by building an actual biogas tank and see what changes we can make to improve the overall design. And during our first term and second term interviews and feedbacks, we were able to get consistent opinions about how people were having issues with the high cost, low efficiency, and high maintenance required to properly maintain the tank. And we looked at numerous designs, such as ferrocement, plastic, and balloon type tanks, and we were able to figure out that the floating drum seems like our best option to go for because they're cheaper and easier to make, and yet it's still really highly reliable and maintainable. So what is exactly the floating drum model? The main difference is another set of wall. This is a conventional design. We just have a single wall holded by on top of it is a gas holder, collecting all the gas from the slurry inside the tank. Here we have another set of wall that has water inside. This water layer keeps all the gas from leaking out, so the main advantage of having a floating drum is that the gas system leak. Therefore, we can expect a higher efficiency and less maintenance required for it.
Okay, so going back to the drawing board and thinking about what we can do to iterate upon this design and improve upon it. After talking to different producers about what the cost breakdown was for the production of the biogas tank, we realized that the cost of the material itself was greatest. And over in India, the primary material that they use to make these tanks is fiberglass and in molds. And so the first thing we thought is simply just reducing the size would be the obvious way to cut down the cost of it. And so we thought instead of making it 1,000 liters, which is typical cubic meter, we'd bring it down to 700 liters. And this also worked out because that was a mold size that our manufacturer actually ended up having. And then so now because we're making the tank smaller, we knew that we needed to address efficiency, since having a smaller tank would have less gas production if it was the same tank, just smaller. So we wanted to implement our waste shredder into this. And we did experiments that showed that shredding the waste improved the efficiency, and so we thought that'd be a good add-on. And then finally, to address the maintenance issue, which, as Archana explained, rises due to the condensation after leaving the tank for a few days, we thought that we would implement a split gas pipe that basically just allows the condensation to drip down into the output box where the fertilizer and waste is that you don't want to use anymore. So that just collects the liquid and brings it down so the gas can have continual flow to whatever your source is.
Okay, then, so next is about the initial prototypes. We had initially 2 prototypes, one in US and one in India. Both are extremely same in the working process, but only difference is that in US it is a double wall tank, and in India it's a partially double wall, in which the outer wall is not a same height as of the inner wall. And we conducted testing the functionality of the design, and both the designs are crude small scale floating drum models, and found that after testing in US prototype, the gas tank rose to 5 inches after 2 weeks. So that's all about it.
So more recently, we created a second prototype in the United States. It's fully functional, and we made it out of trash cans. I guess that's the easiest material to use. The inner waste holder is 75 liters, which isn't exactly what we want, but we're limited by the resources we have available. And then the outer one was 300 liters. We added a shredder at the input, as we talked about earlier, and this is not the shredder that we created last quarter. This is just the shredder you can buy at the store. So we found out that it was much easier to just use existing shredders and also much cheaper. We did not implement the splitting mechanism in the output, in the gas output, which would allow the water to drain out, and that has to do with availability of suitable pipes to hold and transport gas.
Okay, so within this last week, when our prototype was finished, we decided we might as well try testing it. And so we contacted CDS, and on Monday, we got the extra waste from lunch, and we put it in our tank. And so we filled it with waste, and then we filled it with water, but we ran into problems because we didn't secure the inner tank to the bottom of the entire system enough. It ended up rising a little bit, and then that caused the water to leak, the water seals to break a little bit, and then some water started leaking out. And this isn't a problem in India where the entire inner and outer walls are connected together automatically, whereas we're working with separate containers here. And so since we just put it in about not even a week ago, there hasn't been enough time to really rigorously prove the results of our prototype. Additionally, it's cooler over here than it is in Kerala, but I think the primary factor is that there wasn't enough time. And so that's where we stand with testing.
So then, next is about the working with manufacturer. The manufacturer that we work with during this term is NILA. NILA stands for Natural Energy of Land and Action. It's a non-profit organization and it is run by a person, Mr. Shindo. He's an experienced manufacturer. He mainly focuses on manufacturing 1,000-liter biogas tank mold as well as biogas tanks. But currently he is not at all distributing. He has also a mold of 700 liter, but he is not at all manufacturing and distributing the 700 liter because of the huge order of 1,000 liter. So they were a great source of information for us. They also helped us in clearing our doubts and also helps in designing the prototypes and what all we should consider and not consider while designing a tank, etc. However, we will not pursue production in India because our tank has not rigorously proven to be better than the existing one in Kerala. So that's all about.
We learned a lot from this project. One of the most important things we learned was don't rush the initial selection of your product. As we mentioned previously, we spent a lot of time working on a food shredder first term, which turned out to not actually be as helpful as we thought initially. So definitely be meticulous, do your market research, do everything before you start building. Second is try to keep in contact with people who are smarter than you, mentors, manufacturers. They will help you make the correct design decisions because they have the experience. And of course, we weren't able to build that last part, which I mentioned earlier, which will drain the water out of the gas pipe. So if you do need these sort of specialized parts, look for them early. Make sure you look at the competition more closely before you go into these sorts of endeavors. There is a lot of competition in India around biogas. And there are a lot of cheap solutions. There's a lot of expensive solutions as well, which we were trying to be a cheap solution, obviously. But make sure you are actually doing something that's better than what's already out there. And then 5, yay. Biogas is fun. So, cool. Is it?
Yeah.